present topic of discussion is how can we determine whether a chemical change has taken place? How can we say that a chemical change has occurred? So for that there are some observations. One of the observations is change in temperature. So what is change in temperature? Either increase in temperature or decrease in temperature. So there may be an increase in temperature or decrease in temperature. Nothing but heat may be evolved or heat may be absorbed. If the heat is evolved, the temperature will rise. If the heat is absorbed, temperature will decrease. So let's observe both the both of this with two experiments. You can do these experiments at home in presence of your parents. Don't do alone. Don't do yourself, or else ask your teacher to do in your class. Okay. So now buy HCl, a bathroom cleaning acid, which is available in general stores and kirana stores, and baking soda will be available in kirana stores, and aluminium you can buy in electrical stores, right? In any form, aluminium foils or aluminium wires or anything, you buy anything aluminium wires. Now in the beaker or glass container you pour HCl and add some aluminium. The action starts very rigorously and high amount of heat energy will be released here. Here reaction is occurring between aluminium and HCl. Remember, here we have taken aqueous solution of HCl, nothing but HCl in water. Dilute HCl we have taken, and the reaction is occurring between only aluminium and HCl. The reaction between them releases high amount of heat energy. This high amount of heat energy, whether it is high or low, the heat energy evolved or released will be given to the water, the immediate neighboring substance available to it. So as the reaction is occurring in water, the heat energy will be given to the water, nothing but water becomes hot here. As water is in the container glass, so glass also will become hot. So that is why, and moreover you have to remember here that this glass is not a laboratory glass, so there are chances of breaking. That is why this experiment must be done in presence of your parents only or your teachers. And not only this, in any reaction, if heat energy is evolved, the heat energy, if in any reaction, if heat energy is evolved, the reaction is called exothermic reaction. So you may get in an examination a question like, what is exothermic reaction? You can write whatever I told you here along with the experiment. So now heat energy may be observed, same like that. So you take a beaker, HCl, baking soda, and you can hold this in hand. No problem. You can hold this in hand. You can hold this in your hand also. No problem. So if the container becomes gradually cool, it won't become very high cool, but it becomes, you can observe the coolness, you can observe. So here also the reaction is occurring between baking soda and HCl, hydrochloric acid and baking soda or sodium bicarbonate. The reaction is occurring between sodium bicarbonate and HCl. For the reaction to occur between HCl and sodium bicarbonate, heat energy is required. So where they will take the required heat energy from? They will take the required heat energy from the immediate surrounding. As the reaction is occurring in aqueous solution of HCl, so they will take the required heat energy from water. So it means, in other words, it means that water is giving heat energy to the reaction. A substance which gives heat energy will become cool. So that is why water becomes cool. As water becomes cool, in turn the glass beaker also becomes cool and we feel the coolness. So this, and not only in this reaction, in any reaction, if heat energy is observed, it becomes cool, and the reaction is called endothermic reaction. Another observation to determine the chemical change is release of gas. If a gas is evolved, we can say a chemical change has taken place between the substances reacting. One of the examples is, so when acids like hydrochloric acid, sulfuric acid, nitric acid react with metals like aluminum and zinc, so they will release hydrogen gas. And if a burning matchstick is taken near the mouth of the flask or test tube, whatever it may be, so the entire amount of hydrogen gas available immediately catches the fire. As it immediately catches the fire, it makes some noise. The noise is termed in the textbook as pop sound. So the gas which makes pop sound is hydrogen gas, nothing but when it catches the fire, it makes a pop sound. And my personal experience said me that it will make pop sound when the mouth is very small, like test tube. Mainly, it makes a considerable noise here, good noise here with a test tube, but in a beaker. It is a conical flask like it is a conical mouth is small here, but in a beaker it won't make such a noise. But if you take considerable amount of HCl and aluminium, it will burn for a long time. The evolved hydrogen gas will burn for a long time. And another example is if you heat calcium carbonate, which is called limestone, on decomposition it will give carbon dioxide gas. And if you send the carbon dioxide gas through calcium hydroxide is a transparent liquid and it is also called slaked lime. Slaked lime means so there will be lime, quick lime, calcium oxide. If we mix that in water, so after some time, transparent liquid will be above. So the transparent liquid is called actually calcium hydroxide. So if you send evolved CO2 gas through calcium hydroxide, a milky white substance is formed. So nothing but a new substance is formed here which won't dissolve in the liquid. That is why that will be visible here. So a new substance is formed here and the newly formed substance is actually calcium carbonate. So when the gas is sent through calcium hydroxide, if it becomes milky white, the evolved gas is carbon dioxide. It is the test for CO2 gas. So in that way, if gases are evolved in a chemical, if gas are evolved, the change we can consider as a chemical change. We can determine it as a chemical change. Another observation here is there may be a insoluble substance known as precipitate. There may form an insoluble substance which is known as precipitate. So they may ask you in examination what is precipitate. A precipitate is something that a newly formed substance in a chemical reaction which won't dissolve in the solution. So you define in that way, right? Now for observing the precipitation, we have two examples here. Take two beakers, take distilled water in them and add sodium sulfate in first beaker, barium chloride in the second beaker. Stir them so that both of them will dissolve in them. So that you will get a transparent solutions of sodium sulfate and barium chloride. Now mix them. A white colored new substance will be formed and that won't dissolve in the solution. As it won't dissolve in the solution, if you keep it for a long time without disturbing it, slowly that will settle down. So the newly formed substance which won't dissolve in the solution is called precipitate. We have already discussed previously the example. CO2 gas when sent through calcium hydroxide, it will form a new substance again which won't dissolve in the solution liquid. And the newly formed substance also will settle down after some time if we keep it undisturbed. So in this case and in this case, new substance is formed which won't dissolve in the solution, which is called a precipitate, right? So and here the newly formed substance is again calcium carbonate. And the fourth one is there may be observation. Fourth observation is there may be products with different physical states and colors. We observed here white color new substance, white color new substance. So that is why there may be new substances with different physical states and colors. So by one of the four observations, we can conclude the chemical change has taken place. Thanks for watching.